Huh? Oh, yeah. We're going to finish the notes first, though. What? Uh-huh. Now it's Kang and Kane. Wow.
I know what you do, Dan.
Okay, ready? Okay, so we were finishing up power rule yesterday. While you're thumbing through your things, if you want to pull out homework 6, we'll do a couple of examples off of that. So go ahead and just pull that out so you have it ready to go. Okay, y'all ready? Okay, rule number 1. The derivative of sine is cosine. Sine x is cosine x. And the derivative of cosine x is negative sine x. So the derivative of sine is cosine. The derivative of cosine is negative sine. So here's what happens with those guys. When you take the derivative of sine and cosine, they kind of like go in a pattern. So I'm going to give you the pattern, right? SC. You can remember Snapchat, or snow cone. Okay, here's how it works. When I take the derivative of sine, what do I get? When I take the derivative of cosine, what do I get?
Negative sine.
Okay, now, if I wanted to take the derivative of minus sine, it'd be negative cosine. Because what would happen is my sine, the derivative's regular, but then since there's a negative in front, it stays. Now, when I get to negative cosine? Okay, negative cosine, you'd have a negative from here and a negative from here. That puts you back up at the top. Okay? So when you're taking derivatives of sine and cosine, you're going down the ladder. So sine is cosine, negative, blah, blah, blah. You got it, right? Good? Okay. We'll do examples with it, though. Okay, the third special rule. The derivative of e to the x is still e to the x. Wow. And then the fourth and final special rule you're learning today is the derivative of ln x, and it is 1 over x. That's natural log x. Good. Okay? So we're going to do 2 examples in your notes. We'll do a couple off of homework 6. Make sure you got it, then we'll go on to your notes for today. So, examples. Okay, example number 1, you're going to have y equals 4x squared plus cosine x plus e to the x plus 7. You're going to find for me dy dx, and then d squared y dx squared. Let's review what that stands for. So dy dx is the same as what? The derivative, or y prime. Perfect. Okay, so if I wanted to take the derivative, we learned power rule yesterday, you're going to times the 2 down. 2 times 4 is what in the front? 8. And then x was squared, so when I take it down a notch, now it's x to the 1. Okay, then I get to my cosine term. Look at your snow cone. If I'm at positive cosine, and I go down 1, that puts me at negative sine. Very good. So minus sine x. Okay, then my next term is an e to the x. We just wrote that rule. Derivative is still what? E to the x. And then 7 is a constant.
0.
Derivative of a constant we learned yesterday is always 0. Okay, now d squared y dx squared, what does that stand for? The second derivative. So you just do it one more time. So if I'm doing 8x, that's 8x to the 1. So I do 1 times 8 is 8. And then when I take x down a notch, if it was to the 1, now it's to the 0. Do I have to write it? No, just leave it off. Okay, now I'm at negative sign. Look at your snow cone. Snow cone, I'm here. I go down 1, I'm at minus cosine x. Very good. Okay, and then e to the x, it doesn't matter how many times you take the derivative, it's just going to stay an e to the x. Got it? Questions are good. So the derivative of a constant is always 0. So that's why once it kind of goes away, you never even see it again. Okay? Alright, one more like that, then we're going to look at your homework 6. So you're going to have y equals 3x to the 5th plus 2 ln x. Same thing. You're going to find dy dx, then you're going to find d squared y dx squared. So first derivative, and then don't write the second derivative yet because we're going to need a little bit of room for a rewrite. Okay, so first one, 3x to the 5, power rule. You multiply this guy down. 5 times 3 is 15x to the what? 4. You take 1 off, right? Okay, then I get to ln x. What's the derivative of ln x? 1 over x. So it's 2 times 1 over x. Now, if I wanted to take the derivative of that again, I'm going to have to rewrite this guy. So I'm going to put RW. Okay, that stands for rewrite. We learned that yesterday. 15x to the 4 is not a problem. That's already a power. But how can I rewrite x if it's on the bottom? Good. X to the minus 1. And the reason you rewrite it is so that it's written as a power, and then you can do power rule on it. So this and this are the same. The only difference is that this is set up for power rule. We'll say set up for power rule, and the other one's not. Okay? So now that I'm ready to take the second derivative, d squared y dx squared. What's the derivative of 15x to the 4? 60x to the what? Third. Okay, then my next term, I do negative 1 multiplied by 2, I get minus 2. And then when I take away 1 more, it was already a negative 1. So now it's x to the minus 2. Then remember, we're not going to leave our exponents negative, so my x squared is going to go whoop, down to the bottom. So it would be 60x cubed minus 2 over x squared. Okay, but remember, technically, okay, these two bottom rows, really those are the same. The only difference is how it's written. That one has a negative exponent, that one's written as a fraction. Make sense? Okay, so take a look at homework 6. I'm going to give you 3 to do. Ready? First one I want you to do is number 3, number 5, and number, let's do 9. 3, 5, 9. 3, 5, 9. Yeah. Yes. Okay, 3, 5, and 9. What? Which one? Which one? Oh, okay. You got it. And then power rule. Have you kind of seen what we're doing? You're gonna take, so like if I'm doing number 1, you're gonna take whatever the exponent is, you're gonna times it down. So 4 times 3 is 12. Then you take 1 away from the power. So if it was an x4, now it's an x3. Then 3 times 2 is 6, x is now squared. Now, if you get it just for 1, that's like an x to the 0. So you do 0 times 1 is 0. Cancels everything out, I guess. Yes, sure. It's actually, let me grab it for you. Just take the one off the dot cam, and I'll pull another one out for you.
Sure.
Now, that's f prime of x. Huh? Oh. Okay, that's f prime of x. Then if you want f prime of 2, you're just going to put it into. Well, it'd be 12 times 2 cubed. So remember, you still have to follow PEMDAS. So you do the exponent first, then times by the 12 and the 6. That's your exponent. Now, when you do this one, if x is on the bottom, you can bring that up as a negative x. So you would do what I'm calling the 3, right? And you would just write that as 3x to the minus 2 plus 4x squared minus 2. And then you multiply down, and when you take one away, it'll turn into negative 4. Because you're minusing and it's already negative. Make sense? Okay, how we doing? Okay, so the 3, when you do your rewrite, it's going to be 3x to the minus 3. I think you turned it into a 1/3, but the 3's not down on the bottom, just the x's. Yes? When you minus one more from minus 3, you should have gotten minus 4 on the bottom, yeah?
You got 2x.
I'm doing the practice. This is a quiz grade.
How we doing? How we doing? So good? Yeah. Which one? There are a couple of them you can't do yet. But for that one you mean? It looks like you did, that'd be 2x cubed, 3x squared, minus 4, derivative would be 6x squared plus 6x, 3 squared is 9, that's 54 plus 8, 9, yeah, looks good.
Do I use calculator for my number 9?
No calculator.
I don't know how to do
I'll show you how to do it though, we're about to do it together anyway. Isn't that one of the ones I picked?
Yeah.
Okay. Alright, let's look at number 3, let's see if you got it right. The first step you should have done is a rewrite. How do you rewrite that guy?
3x to the negative third.
And then the 4x squared and the minus 3, those were already fine. Now remember, that does not count as you taking the derivative. You're just rewriting it in a power form so that you can do power rule. Okay, so when I go from y to the derivative, I call it y prime. Okay, negative 3 times 3 in the front is now a what? Then I need to take 1 away from negative 3. What do I get? Negative 4. Next term, 2 times 4 is 8. X is now to the 1. What about the minus 3? It's a constant. Derivative is 0. Then when I want y prime of negative 1, that just means I'm going to plug that in. Now, I don't want to plug in with negative exponents. So I'm going to rewrite this as negative 9 over x to the 4. Plus 8x. Remember, this and this, those are the same. Okay, it's just however I want it to look where it's easier for me to plug into. Now, from here, if I'm plugging in a minus 1 to a 4th power,
That's negative 1.
yeah, but it'll turn to a positive. If it's to a 4th power, you'll have 2 and 2. They cancel out. So that's going to stay a negative 9. And then negative 1 times 8 is going to be minus 8. Negative 9 minus 8 more. Good. Were you close?
Wait, I got positive 1 because of the 4.
Oh yeah, you did 5.
Because negative 1 times negative 1 is 1. Times negative 1 is negative 1.
But you did plus 8, I think.
And then times another negative 1 is 1.
Yeah.
Okay, hold on. If you have 4 negative 1s,
Yeah,
right?
because negative 1 to the third is negative 1.
Yeah, and then times 1 more turns it positive. Yeah, the reason it's negative is because the 9 was negative. Yeah? Because you multiplied the minus 3 in the exponent from the rewrite, that's where the negative comes from. Yeah?
So that's negative 17.
Yes. Okay, next one. You should have done a rewrite. Okay, you should have done 4x to the 4th over 2x. 6x to the 3 over 2x. 8x over 2x. Remember, we haven't learned any rule for fractions yet. There is one, but you don't know it yet. So you're going to simplify it first, make it a regular power, and then just apply your regular power rules. What does this simplify to?
2a squared.
Squared? Cubed. Okay, then next one. 6 divided by 2 is?
4a squared.
Close. 3x squared. Then last one. Come on, Yoshi, give it to us.
X.
What? 8 divided by 2?
Oh. -4x.
Negative 4.
X, gone, right? Because your x's, they cancel out with each other. Okay, so now keep in mind, this is the same as the original. I have not taken the derivative yet. So I break it up, simplify it first, now I'm going to take the derivative. So derivative will be called y prime. What is it?
6x squared
Plus.
plus 6x.
Yup.
That's it.
What about the 4?
That's it.
Derivative is 0. Very good. Then from there, I'm going to plug in my value, which is 3. So y prime of 3 equals 6 times 3 squared plus 6 times 3. 3 squared is 9. 6 times 9 is what? 3 squared is 9. 9 times 6 is 54. Oh, and then the second one is 18. Okay, cool. And then from there, add it up, what do we get? Perfect. Perfect. Huh? And then last one was 9, right?
Yeah.
Okay, look at number 9. No rewrite necessary. We're just going to have to use our special rule you just learned. Okay, derivative of 6x, what's that? Just a 6. And then negative cosine. Snow cone, snow cone.
Positive sign.
I'm at negative cosine. Then when I go up, I'm at a plus sine x. Okay, remember, you're on your little snow cone ladder. And then from there, we're plugging in pi thirds. So y prime equals, oops, I should have put a pi thirds here. 6 plus the sine of pi thirds. Okay, to hand trig, pi thirds is here. 0, pi 6, pi fourths, pi thirds, fold it down. Sine's on the bottom, so it's root 3 over 2. So your answer is 6 plus root 3 over 2. And you would leave it just like that. Good? Or you can just do unit circle. Either one. Okay, ready? Turn to the back page. You need a tissue? I have tissues. Ooh. Oh, hey, listen, okay? Don't make fun of a cripple. Now you feel like a bully. No! Look at me crippling over to get you your Do tissues expire? Surely not.
Probably they have big.
Watch them be expired.
There you go. Okay, number 11, we'll do A or B, which one? Doesn't matter.
A.
A? Oh. Okay, look at your equation right here. Okay, it says take the derivative. We know how to do that. So the derivative of y is called what? Y prime. And then what is the derivative of f of x called? F prime of x, right? Don't overthink it. So it would be 3f prime of x. Now, what's the derivative of e to the x? Still e to the x. So remember, the derivative of f is just f prime, and then you're plugging stuff in from there. So what am I plugging in? Look right here. I want dy dx when x is 0. So y prime of 0 would be 3 times f prime of 0 plus e to the 0. Huh? What will stay the, huh? Were you asking about e when it's...
Yeah.
So it actually doesn't always stay the same, but we haven't learned that rule yet. So if it's regular e to the x, it will always stay the same. But if it's like e to the 2x or e to the 3x or something like that, it does change. Okay, now from there, how do I know what f prime of 0 is? Look at the sneakiness. Okay, what's f prime of 0?
5.
So it's just 3 times 5 there. 15 plus e to the 0 is 15 plus 1 is 16. Got it?
Got it.
Cool. Okay, you can't do 16 and down, so if you want to put like a little, you know, or something.
Cross them out.
No, don't cross them out because we're going to cover them. We just haven't covered them yet. So if you're working ahead because you know it's due on Friday, then don't try to do those yet. What are the instructions on 13 asking you to do?
Find the second derivative.
Okay, that's the second derivative. And then when you get to number 14, y to the 3, that's the same as y prime prime prime. So you'd be taking the third derivative. What about y to the 5th?
Wait, so,
1, 2, 3, 4, 5.
so is that first one right there? That's the first derivative?
No, you're finding, that's the original, so you're taking the derivative twice. So let me put find second derivative. Okay?
Got it.
Good. Okay. So switch to the notes you picked up on the way in, please. Will you get me one too? Yeah, you just the stapled. Not really a packet, just 2 little pages, you know. It's been good. Oh, horrible. Now, you know, I have kind of like big legs, so now this boot's really just like digging into my fleshy leg. And look at this bruise. Look at this. You want to see it? Ugh. Look at it.
Oh,
Can you see it?
that's huge.
I feel like you can't see it, but it freaking
I can see it.
like is throbbing. I don't even know how one person can hit you that hard. You know?
I play softball and I don't think I've gotten a bruise.
I bruise pretty easy. Like when I played softball at Huffines, I was on like a for fun league, and so I was playing first, and someone I was running to first, and someone threw it to first and hit me in the leg, and I had like a freaking
As
huge.
a first baseman, I get hit in the shins a lot. So
Yeah.
this season I would have bruises all the way up my shins.
Especially if it hits in the back, I feel like it's fine. It's anytime it's like on the front.
And then
But I'm like-
my strike zone is kind of hard to reach since I'm tall. So a lot of times, like they throw an inside pitch, but it goes too inside, and so I get hit in the thigh. That hurts. Some pitchers, okay, like they're throwing soft, and I can hit those. But like some of them are some pretty hard pitchers.
Yeah. All right, ready? Okay, so you are going to learn another way to fix limits. Okay, it's called L'Hopital's rule. Okay, L'Hospital, if you don't want to have to pronounce it like, I don't know, the French do. It's L'Hopital's rule though. Okay, oui. Okay, here's how it goes. If you have a limit where the top and the bottom limits both come out to 0, so look right here. If the limit for f is 0 and the limit for g is 0, then you can rewrite this limit as f prime over g prime. So you're still taking the limit as x approaches whatever that value is, but you're going to take the derivative of the top and the bottom and then try the limit again. So here's what's annoying about this theorem. When I go to do number 1, it would be very easy for me to just put, oh, it equals, what do I get when I plug in 2 on top? Okay, 2 cubed is 8. 8 minus 8 is 0. Then I go to the bottom, 2 minus 2 is 0. And then be like, oh, L'Hopital's rule. On the AP test, if you write this, you get no points. They stop reading it, they count it wrong. So rather than doing that, you have to use the theorem which shows the limits separately. It's annoying, but you can do it. So instead of writing it like that, cross it out, you're going to put that the limit as x approaches 2 of just the top came out to 0, and the limit as x approaches 2 of the bottom came out to 0. The reason why is you're never allowed to divide by 0. So if you put that something equals 0 over 0, okay, technically that's wrong. They're not going to keep grading your paper for the AP test. So you would write those limits separately, and then it's allowed. So my top limit came out to 0, my bottom limit came out to 0, then I'm allowed to use this rule. So, equals the limit as x approaches 2, and then I'm going to take the derivative of the top, take the derivative of the bottom, and then try the limit again. So on top I have an x cubed minus 8. What is the derivative of just that piece of the fraction? 3x squared. What about the 8?
0.
Constant goes away. Okay, on the bottom, my function was x minus 2. What's the derivative of x minus 2? 1. Now, when I plug in, do I still get 0 on the bottom? No. So I plug in x approaching 2. Put your 2 right here. 2 squared is what? 4. 4 times 3 is 12. That's your answer. Okay? Go down for me, please, to number 5. Number 5. We're going to come back and do that top one in a second, but jump down to number 5. Okay, number 5. I have the limit as x approaches 3. What do I get when I plug into the top? 0 over 0. And then I'm like, wait, I don't want you to count me wrong. So I'm going to cross it out, write the limit separately. So, limit as x approaches 3 of x squared minus 9 is 0, and the limit of x minus 3 is 0. You have to write them separately to use L'Hopital's rule. Now, let me also say, if it was multiple choice, they're not going to look at your test anyway, so it doesn't matter. This is if it's a free response, you'd have to separate them, okay? So, from there, I'm going to put equals. Limit as x approaches 3. What is the derivative of the top, which was an x squared? 2x. And then what about the 9? Goes away. It's a constant. On the bottom, I had just a regular x. Derivative of regular x is 1. Okay, and then from there, when I plug in x approaching 3, what do I get? 6. Now, my kids, okay, that you've been in this class, you already knew how to do that from what? You could have done this question on your test. How would you have done it differently? Factor, cancel, fix it. Yes. So how would I factor the top of that? Minus 3 and plus 3. Then what would happen to the x minus 3's?
Cancel out.
What would you still get when you plug in 3? 6. So L'Hopital's rule can solve all of your factor especially if you suck at factoring. L'Hopital's rule will always get it right. Okay? Now, you might be wondering, okay, well, why would I want to learn this? Okay, go back up to number 2. Do you know how to factor it if it's cubic? Like this one?
Oh, that make it complicated.
No, probably not. That makes it complicated, but L'Hopital's rule can still fix it. So, if I plug in 2, okay, write your limits separately because we're going to practice doing it right. You're going to have the limit as x approaches 2 of just the top. So I have x cubed, 7x squared, plus 10x. We're plugging in 2. Just to the top for now. What's 2 cubed? Minus. What is 2 if I square it? So 7 times 4 is what for this term? 7 times 4 is 28. And then what about 2 times 10? 20. Put all that together, what do you get? 0. So I got 0 on the top. What do I need to get on the bottom to use L'Hopital's rule? 0 again. So if I have x squared plus x minus 6, 2 squared is 4, plus 2 in the middle, minus 6. Do I still get 0? Yes, and if they both come out to 0, you can use L'Hopital's rule. Take the derivative of the top, take the derivative of the bottom, apply the limit again. What is the derivative on the top? 3x squared minus what? 14x plus 10. What about on the bottom? 2x plus 1. And then what do you still keep in the front? The limit as x approaches 2. So remember, you're taking the derivative of the top and the bottom, and then you're trying to, again, now look at the bottom. When I plug in 2, am I going to get 0 now?
No.
No. Okay? On top, I'll have a 2 squared. 2 squared is 4, so I have 3 times 4 minus 14 times 2 is 28 plus 10. Okay, so that's 12 plus 10 is 22.
-4.
Close?
6.
Negative 6. What do I get on the bottom?
5.
5. So your answer would be negative 6 over 5. You got it. Good job.
I go by this.
Good job. I got you. Okay, now, does this look familiar?
Yeah.
That's one of your specials. You were supposed to already know that, but let's say you forgot. L'Hopital's rule can fix it. What's the cosine of 0?
How do you say it?
L'Hopital.
L'Hopital?
Yeah. Okay, plug in your 0. Cosine of 0. Is that a crippled joke? Oh, so now I have to go to the hospital. Oh, so funny. Just kidding. Okay, write both your limits separately. Okay, so we're plugging in 0 first. Cosine of 0 is what? 1 minus 1 is 0 on the top. Then I have an x on the bottom, but x is approaching 0. What do I get? 0. Then from there, this tells me 0 over 0. I can use L'Hopital's rule. So take the derivative of the top. What's the derivative of cosine x minus 1? Derivative of cosine is negative sine x. What about the minus 1?
That's a 0.
0 on the bottom. What's the derivative of x? 1. And then I plug in 0. What's the sine of 0? But that was already one of your special limits. You should have known that was 0 just from it being on your pink sheet. Okay, now here's where L'Hopital's rule comes in handy. Take a look at number 4. Can factor cancel fix number 4? No. E to the x on top, sine x on bottom, those aren't going to cancel. Also, there's not a special rule for that. But when I plug in 0, what is e to the 0 on top? 1 minus 1, which gives me 0. On bottom, what's the sine of 0?
0.
Then that tells me I can do L'Hopital's rule and fix it in a different way. So, x approaching 0, e to the x minus 1 is 0, and the limit of sine x is 0. And because both of my individual limits, top and bottom, came out to be 0, I can take the derivative of that guy. What is the derivative of the top?
Just e to the x.
Just e to the x. X is still approaching 0. And then on the bottom it was a sine x. What's the derivative of sine x? Cosine x. And then now when I plug in 0, what's e to the 0 on top?
1.
Cosine 0 on bottom?
1.
1 divided by 1 is
1.
1. Make sense? 41, 50. Oh, we got 10 minutes. Okay. Next one, number 6. Okay, do I need L'Hopital's rule on number 6? No, why not? Because the top and bottom don't what?
Don't equal 0.
They don't come out to 0. No L'Hopital rule because top and bottom aren't equal to 0. Okay? And it is spelled La Hospital if you want to sound it out. Huh? Yup, you can sound very French. Okay, so all you would do, if it doesn't give you 0, just plug it in, just like you did on your test. So on top, what would I get when I plug in 0 to x plus 6? 0 plus 6 is 6. What would I get on bottom? 0 squared minus 1 is negative 1, so it's negative 6. Okay, numbers 7 and 8. Give them a shot. Number 7. Do you get 0 on the bottom?
Yeah.
So you use L'Hopital's rule?
No, 'cause you don't.
No, you don't get it on the top. You can't use it. So on the top, my limit as x approaches 3 of e to the x is e to the 3. Now, you may not know what e to the 3 is, but is it 0? No, then no L'Hopital's rule. You have to get 0 both on top and on bottom. So that would be e to the 3 over 0. That is not allowed, so what's your limit? Okay, and remember, you need to cross out the divided by 0 because they will count off for that on the AP test. So I got e cubed on top, I got divide by 0 on bottom, slash it out, DNE. They're really strict on that, like in the last 3 years. Even though they didn't used
So
to.
what if I forget to put a slash, but I got D&E and I circled D&E? Like,
Yep, toast. Well, if you circled DNE, then you might be fine if you circled it to show that that was your final answer.
Yeah, I'm gonna circle all my S's on the test.
Yeah. All right, number 8. Do I get 0 top and bottom? Check it. Yes. Okay, this one, put a star next to this one. So I have 2x squared, plug in 0, you get 0. Okay, then I'm going to do the limit as x approaches 0 of e to the x minus 1 minus x. Remember, we're still plugging in 0. E to the 0 is 1. 1 minus 1 minus 0 is 0. So can I use L'Hopital's rule? Okay, do it. So my L'Hopital's rule comes out to be the limit as x approaches 0. What's the derivative on top? 4x. On the bottom, what's the derivative?
E to the x plus 1.
Minus 1. Now this minus 1 crosses out, right? But the minus 1 is coming from the minus x. Okay, now plug in 0. What happens again?
0 over negative 1.
0 over
Oh, 0.
0. Double L'Hopital's rule.
D&E.
Nope.
No?
Double L'Hopital's rule. You got to do it again.
Again?
Yep. Now, I'm not going to make you write out the one-sided limits, but if you get 0 on top and on bottom, you do L'Hopital's again. So on top, what is my second derivative now? 4x. What's my derivative of e to the x minus 1?
Not 4x.
No, it's just 4.
Oh, just 4, thanks. My bad. Crippled guys, don't pick on me, okay? E to the x minus 1, derivative's just e to the x. Then I plug in 0, what do I get? 4 over 1. So put a little star and I want you to write that's a double L apostrophe H. And you can always abbreviate it L apostrophe H and they'll know what you mean. Okay?
Yeah, we're not saying like Kylie.
No, definitely not. Okay, last thing I want you to do. Turn over to your homework. The one you picked up on the way in. Okay, I'm going to give you 4 to try. Okay, and you're not doing this whole homework, so don't mark it, like put it at the top, don't do it. Okay, I only want you to do the following questions. I want you to just do them now. Ready? Number 7. Number 8. On the homework you picked up on the way in. So 7 and 8 right here. 7 and 8. I'll get it for you. Then 13, 14 on the back. 4 questions only. Don't do all of them, just do those 4. 7, 8, 13, 14.
Dude, where's school 7?
Homework 7 is not due on Friday. Homework 6 is, but homework 7 is.
Well, I told Miss Reinhardt and then, oh wait,
Did she say, she said yes?
I haven't told her yet, but I haven't.
Okay. 7, 8, 13, 14. Now, let me also say, guys, that you're gonna play the way that you practice, okay? So, if you don't do your homework showing the limits separately, you'll probably forget to do it when you take a test. So, I would practice the right way.
Wait, Miss Jordan,
Yeah.
you mentioned line number 7 to me, so I can like do it.
Okay, so you're gonna plug in 0 top and bottom. No, because the 0 is 1. And then e to the 0 is 1. So then minus them, you get 0. On the bottom, 2 times 0 is. That tells you you can do little functions. So we're equal to the limit. 7, 8, x approaching 0, and then you take the derivative separately. So on top, what's the derivative of cosine? And then e to the x is, we'll put in x for your sine. And then minus your sine. On the bottom, what's the derivative of 2x? Sine of 0, and then plug in negative sine of 0. Sine of 0 is 0. E to the 0 is 1, so it's negative 1 over 2. Now, technically, you should be writing these limits separately equal to 0, like we did on the no thing here and here. So technically, you should break them up as separate limits. We did that part of your head. But you would put the limit as x approaches 0 up at the top equals 0. Limit as x approaches 0 up to 2x. Make sense?
And Mr. Tuberculosis.
You should get what for 7? Anybody got it?
Negative 1/2.
Yes. Yes, you can do it. If you didn't get it, I love to help. You need help? Okay. So you're slipping it out, huh? Yes. My guy right there.
That's the only time you do. You tell on their slides always have to know.
Let's do it.
Did you not eat lunch, Jared?
I don't want
So pretty much every day except like Tuesday, Wednesday, Thursday, I usually stay. And then if you need to come in the morning, if you just message me on Remind, I don't just sit up here in the morning. Sometimes I get here at 8:30. I have first call. Sometimes I get here at like 9. But if you message me on there and say, hey, can we meet tomorrow, I'll probably stay.
Miss Jordan,
Yeah.
you have first period off, right?
I do.
I have first period off, and you learn your first period?
Sure. When? Tomorrow? So I'm gonna say probably yes. I have to finish grading y'all's second test. And so, well, I guess if you don't come 7th, I can grade it 7th. So then, yeah.
I can't come, I'm pretty sure I can't come. That's what you
Oh, crap.
Then let's choose tomorrow. It is a double! 8
Miss Jordan.
is, yeah, because when you plug in 0, you get 1 minus 1.
Can I put 2
Why?
LH? Can I put 2 LH to show that it's double?
You could, but I just wouldn't. I would just do it again.
Oh, not even label it?
Yeah, what time are we at?
You want me to come in at 8:30 or at 9?
You can just come in at 9, it's fine. Because we'll still have the whole period. Okay, if you need help with 8, we don't have very long, but did you get 0 over 0 the first time? Yes, so you took the derivative on top, what'd you get? Derivative of 1 is?
Not there.
Derivative of negative cosine is? Positive sine x. What's the derivative on bottom? Okay, then I plug in 0. What happens?
Get 0.
Oh, bell ring. We'll do it tomorrow.
I got 1/2. I got 1/2 too.
Oh, yeah, that's right.
Yay!
Bye, Yoshi. Can't wait. Bye. Have a good day, Kate. Is that right?
Not this Bethany.
Bye. See you guys soon. Can't wait. Catch that scene. Bye.
I'm just living my life out of it.
Bye. See you tomorrow.
How do you live your life without